My name is Isaac Levin. I am a .NET developer advocate at a small company called AWS, if you've heard of it. What I want to do throughout the next hour, I don't want to talk for an hour straight. If people have questions, please just interrupt me. I think there'll be a time, I'll try and make some time for question and answer. You can obviously talk to me afterwards out in the halls or well if you want. But I was kind of talking before to the people that are trickling in. I want people to know there are options for .NET. You don't need to just host your apps in one particular cloud. You can host your apps anywhere, right? So throughout this talk, we're going to be talking a lot about the different ways that you can run .NET apps on AWS and talking about some of the things that AWS has done to make the life of a .NET developer a little bit better. If you like the way that I talk and you think that I'm a cool guy, you can follow me on the different tech social media platforms. So I'm on Twitter and GitHub, obviously. I also have a Twitch show. Actually, it's the .NET on AWS show. Coincidentally enough, that's every other week on the AWS Twitch channel, if you're interested in that. I also host a podcast called Coffee and Open Source, where I interview random people in the tech space. I've interviewed people like Scott Hanselman and Kelsey Hightower and all sorts of really, really awesome people, if you know any of those names, not to name drop. So with that, let's get started. So what do .NET developers typically ask me about AWS? What are some of the questions that you have right now, other than why are we here?
What does it cost?
What does it cost? It depends. Anybody else? Questions? Well, some questions that I get are, does AWS support .NET? Raise your hand if you think AWS supports .NET. Raise your hands.
Otherwise you wouldn't be here.
Well, I mean, breaking news. Another question that I get a lot is, does AWS provide tools for .NET developers? Do you think that's true? Somewhat. Not as many people as the first one. I have a feeling as we go down this list, less and less people will raise their hands. That's why I'm here, right? The third question that I get a lot is, can I host my .NET applications on AWS? Raise your hand if you think that's true. All right. People are like, do I got to raise my hand this entire time? I did not sign up for this. How can I containerize my .NET applications? I imagine a lot of you realize that you can run .NET apps in Linux, which means you can run .NET apps in containers on Linux, right? Also, how can I move from .NET Framework to .NET? Who knows you can do that? Not very many people, because it's hard in a lot of cases, right? And then how can I break up my .NET monolith? Obviously, we talk about microservices a lot if you go to tech events. But a lot of us have been building applications for the last 20 years, because .NET's 20 years old. More than likely, you didn't build a microservice architecture application 20 years ago. You wrote it in web forms, and you had your ASPX code, and the code behind was like 70,000 lines long, because that's how we built applications at one point in time. Anyway, so the most important key takeaway that I want everybody to take from it, everybody can take pictures of this and tweet it and whatever, is AWS loves .NET, right? That's the only thing. Everything else, it's not really useful. Everything else is nothing compared to this. So how does AWS support .NET? That's the first question, and here is a graph with nothing on it yet. But as we go through the years, and I go through different things that happen in the Microsoft ecosystem, AWS has been supporting Windows Server since 2008, right? No other clouds were around back then. If you take a look at SQL Server, 2009, support for SQL Server, all the way up to today, obviously. And then when you talk about .NET, there's a lot of stuff here, right? But if you look here, the SDK for .NET in 2008. So for, 15 years, roughly, AWS has been supporting .NET. All the way to the very, very tippy top, which is AWS Toolkit for Visual Studio. And I'm going to talk a lot about different services and tools and things like that, and these things in pink are some of the different modernization tools that we have to get you from .NET framework to modern .NET, right? But at the end of the day, it shows that AWS has a never-ending commitment to .NET, starting 15 years ago all the way to today, and it's only continued to get better. So Did I answer your question, does AWS love .NET? Well, I mean, they spent money, at least. Money means love. At least that's what I tell my kids. How does AWS provide, or does AWS provide tools for .NET developers? We talked a little, I had people raise their hand, and some people were like, yeah, okay. So let's talk about some of the tools. So one of the things that's really important to call out is that if you are a .NET developer today, you more than likely use an IDE. Unless, does anybody here like write their .NET apps in like Vim or Emacs or, that you hate your life? No? Okay. You all use an IDE, right? Visual Studio, Rider, VS Code. There's first-class IDE integration. So we have Visual Studio extensions, we have Rider plugins, we have VS Code extensions to be able to write and deploy .NET apps to AWS. We also have programmable SDKs and what we like to call the CDK, which is the Cloud Development Kit. Think of it as kind of like programmatically writing infrastructure. So there are other tools that do that, like Pulumi. So it's that in a AWS mindset. We also have a lot of command line tools because now in modern .NET, command line is awesome, right? You can build all sorts of amazing things in .NET without ever having to go into an IDE. So we have things like the AWS CLI or SAM, which stands for serverless application model. So be able to deploy serverless applications to AWS all from the command line. And when it comes to CI/CD, because, to quote my friend, Damian Brady, we don't let our friends don't let friends right-click publish in Visual Studio, right? I'm going to show you a demo of right-click publish in Visual Studio because all I do is build demos for a living. But anyway, CI/CD is very, very important. So whether you're using Azure DevOps today or GitHub Actions or even something new like Amazon Code Catalyst, which is a new service that we just announced in November, which is like an all-encompassing DevOps platform specifically for AWS, you can build and deploy your applications in your CI and CD in a very effective way. And then finally, when it comes to modernization and migration, we have a set of tools that you probably have never heard of, and that's kind of why I'm here talking about them, to help get your applications to the point where you want them to be. And I'll talk a little bit more about all the stuff on the screen as we go through this talk. So the next question then becomes, how can I host my .NET applications on AWS? So I have this, I apologize, it is not the most beautiful flowchart, but hopefully it's clear enough to get you to where you want to go. So let's talk about first .NET application migration. So do I want to target a VM or do I want to go container or serverless? I want a VM. Do I want to manage that myself or do I want AWS to manage it? If I want to manage it myself, I can use Amazon EC2. Has anybody heard of Amazon EC2? Well, you're going to hear about it a little bit more. So what is Amazon EC2? So Amazon EC2, and it's the most easy way to summarize it, it's a VM, right? So it's a virtual server, and it has a list of different capabilities mapped on particular categories. So the ability to choose your processor. You can use Intel, AMD, you can use ARM, for instance. You can define the memory footprint, how fast your processors are, how powerful your networking is, and basically customize it to your heart's content because you own it. It's a VM. It's very, very similar to the experiences that you have having VMs in other clouds or even VMs on-prem. So, but the additional things that you get on top of just a VM is you get access to capabilities that are built into AWS to make your life better, like EBS, which is basically the ability to have better load balancing, have better elastic interfaces as it pertains to our networking. So at the end of the day, you get these additional things, and you get over 400 different types of VMs that you can create. I mean, you think about it, and it's like, okay, I have a lot of options there. Maybe depending on my use case, I want more processing power here, or maybe I want more disk space here, or maybe I want faster networking here. You have that configurability built in. And one of the things that I love to talk about with EC2 is that when we think about building VMs, we typically are like, okay, this is going to be x86 or x64, more than likely x64, and I'm just going to party on it the way I want to. But we have a VM SKU list called Graviton, which is the most price performant VM in EC2. And why is that the case? Because it's an ARM processor. So depending on what capability you want, this is how much faster it is running versus traditional x64 architecture. So if you have particular workloads in mind, like vector instruction or floating point, you need to be able to calculate really, really fast. These are some of the multipliers that you get. Whoops. These are some of the multipliers that you get. So at the end of the day, it's really, really important to think about, OK, what am I trying to build? And one thing that's also is really important to call about this is typically less expensive, too. Because ARM processors, as we all know, use substantially less power to run. So let's take a little look about hosting .NET apps on Amazon EC2. So I'm going to hop out of this, and I'm going to go into something that you may have not seen before, but this is the AWS console. This is how you interface with different AWS services if you're not using the CLI. And I zoomed in, so that's the reason why it looks terrible, but I want to make sure that everybody, whether they're watching here or they're watching in video, will be able to see it in the future. So what I want to do is I want to go to the EC2 section. So yesterday, I created a Graviton instance in Frankfurt, which is the AWS, or I believe it's AWS, EU Central. So basically what this VM is it's a Graviton Linux VM that runs Ubuntu 22. So I've already configured .NET 6 on here, but I want to be able to connect to it. So one of the great things that I can do here is I can click connect and go to SSH client. And when I created the VM, I had the ability to configure SSH connectivity right out of the box. So it downloaded me a PEM file, and I can actually take this little command here and go into. So you can see there's a PEM file. I'm going to zoom in a little bit. And I can just run that command here, and it'll connect to my EC2 instance. So right now, I'm SSH into it. So I could do something like uname-a. And if I go here, you can take a look. Whoops, wrong one. Whatever, you see that. So, so as you can see here, it's an ARM processor, right? So, and as you can see also, like I installed .NET on here. Whoops. .NET info, if I could spell today. So as you can see, I have the .NET 6 runtime in the SDK on here. So also what I did earlier is I created a web API. So let's just drill into this API. And this is just, API. So this is just like .NET new web API. Nothing really exciting, right? But what I can actually do is I can run this because in the newer versions of .NET, you have access to Kestrel, so you can actually host web applications without IIS, without Nginx, without some proxy server. I can actually just run using like .NET Run here, and it'll actually run my application. What I want to be able to do is I want to specify particular URLs. So here, let's just go HTTP. And what I'm doing here is I'm specifying which particular port that I want .NET to run under. So HTTPS, and then this is star. Sometimes I get this nomenclature wrong. If I hit enter, hopefully everything works. Cool. So as you can see here, I have a .NET 6 application running using 5000 and 5001 ports. That's really exciting. Let's see if this actually works if I use it if I access it in the browser. So at this point in time, you probably are thinking, OK, so that's running in my instance. However, you probably need to open up a port to be able to access it, because it's running under the 5001 port. So I can do that by going to security. And as you can see here, I created a port earlier today. I'm probably going to need to update this because my IP probably changed. So let's just do that. Let's go to my security groups, scroll down. And as you can see here, I have some inbound rules. So I have SSH. Let me zoom out of here so I can actually read it. So I have SSH and HTTPS and HTTP. And then I also have this custom TCP endpoint, which is an IP address. Let me just change this to my current IP address. So now what I should be able to do is I should be able to go back into this instance and open my address here. And this is going to fail because initially it's going to take me to a place that doesn't exist. But if I go like this, 5001, weather forecast, and then say, yeah, I want to accept this really unsafe SSL, this is just the output of like a typical weather forecast example, right? So really silly demo, but it shows you that I can, in the matter of minutes, go from not having anything to have a .NET app running in EC2 and AWS. That's kind of cool, right? Like, I mean, who wants to run our .NET apps in VMs? But you can. And this app, it saves me lots of money because who wants the weather, right? Everybody wants the weather. Anyway, so let's go back. Oops. Current slide. All right, so that's one demo. So let's go back to our flowchart. The next question then becomes, maybe I want my VM managed by AWS, and we have Elastic Beanstalk. So here's a reason why Elastic Beanstalk is interesting, right? So I just spun up an EC2 VM just now, but no one is going to be able to use that app, right? Because if I get traffic to it, it's like I need to be able to load balance, I need to be able to configure security, I need to be able to do all these things. So what Elastic Beanstalk provides is an ability to have that same EC2 experience, but with built-in services that are provided by AWS to make your life better. So like I mentioned, application load balancer built in by default. And then being able to split out across different web server instances. Route 53 is our DNS service, so the ability to configure DNS at that level. And then be able to configure auto-scaling groups right directly from the console. So a lot of these things you would have to do by hand, right? If anybody has done VMs on-prem, and you've had that experience of okay, need to make sure the load balancer is working, need to make sure the DNS is working, need to make sure that we have additional capacity to spin up new VMs in the case where our apps are under load. All of this is handled for you with Elastic Beanstalk. So pretty cool stuff. And it's provisioned automatically inside of the Elastic Beanstalk environment. All right, so that's rehosting. So that's just taking your existing virtual machines today and moving them to AWS. How exciting is that? Pretty exciting, right? No one is nodding their head. Just for the people that are watching at home, no one is excited about rehosting .NET apps. However, what if I want to go down the path of using containers or serverless? So who here is interested in containers or serverless? Most of you raise your hand. Cool. That means that exciting people are in the room. If you want to build applications that run in containers in AWS, one great approach for storing the definitions of your containers or the images is using Amazon ECR. Stands for Elastic Container Registry. So it's a fully managed container artifact registry. So you can do things like set up private feeds from Docker, for instance, and go directly into ECR, which makes building out new container instances substantially faster because they're in the AWS network. You also have the ability to configure individual security permissions based on different services at the ECR level. And the reason why this is really successful is because all of our different container services, and we'll talk about all these different container services in a second, all of them plug directly into ECR by default, which makes your life substantially easier when it comes to building these apps. All right. So are you building a .NET framework or .NET? .NET Framework, right? Because .NET Framework is the best. Right. So if I'm building a .NET Framework app, am I using serverless containers? Wait. Serverless .NET Framework containers. That doesn't sound right at all, right? So I'm not going to do that because that sounds terrifying. Okay, .NET Framework's apps that are running in Kubernetes. That sounds even more terrifying. I don't want to do that. So let's go down this path of using Amazon ECS for hosting managed Windows containers. Because what if I told you that you can have Windows containers as well? Most people probably know that, but a lot of people get very interested. They're like, what's the benefit? Well, it's smaller than Windows. It's still Windows, but it's not the same. It's definitely not as heavy as all of Windows. So let's talk a little bit about Amazon ECS. So Amazon ECS, or Elastic Container Service, you might have realized that the word elastic is used a lot. We like using the word elastic at AWS to talk about how we can really build interesting things in the cloud. But this is a typical example of how you would do something using ECS. So code pipeline, that's kind of our de facto I guess you could say, CI/CD mechanism. We have Code Catalyst now, but Code Pipeline is like the more traditional one. So one of the things very, very interesting about ECS is that at the bottom layer here, we just manage a bunch of EC2 instances. But when we talk about running containers, there are containerized EC2 instances that have built-in CloudWatch metrics and load balancing built into them. So your user hits your load balancer, user hits your load balancer, hits the application, and then all of this other stuff is configured for you and managed for you using ECS. Okay, so that's one container example. What if I do want to use Kubernetes? Who here uses Kubernetes today? Who here likes using Kubernetes today? Oh. All right. So I just want people to know, if you weren't watching, like half of the people that use Kubernetes like Kubernetes. So that's pretty good ratio. So let's talk a little bit about EKS, Elastic Kubernetes Service. Again, another Elastic named service. So if you're not familiar with Kubernetes, it's basically taken over as the de facto microservice type of framework, heavily used in the community, and it just provides amazing opportunities to be able to do interesting things. So the question becomes, why would I use like EKS over ECS? Well, for instance, if you're building ECS, you need to do things like service discovery, secrets management, load balancing. You need to do all those things separate, outside of the service. You need to use another AWS service for like Route 53 or Elastic Load Balancer or something like that. With Kubernetes, all of that stuff is built in. It's a core components of the framework. So you get access to all those things without having to separately manage them. And that's just one of the benefits of Kubernetes. I'm not a Kubernetes expert, but I think at the end of the day, if you're familiar with Kubernetes today, we have a managed Kubernetes offering in AWS. One of the benefits to Kubernetes is that you can take Kubernetes and go anywhere. You can go between clouds. You can go from on-prem to the cloud, pretty straightforward if you're running Kubernetes on your own local infrastructure. But at the end of the day, you have options and tons of flexibility. All right, so at this point, we've talked about ECS and EKS. So let's go back to our question about serverless containers. I want to run my containers, whether they're in ECS or EKS, but I want to run them I want to have them completely managed. So then we have Fargate. So what is AWS Fargate? So this is an example I showed a little bit earlier of ECS, right? So exact same diagram. The difference between Fargate and ECS is that this part here, I keep on clicking the wrong button. So Fargate here is a managed service. So basically, when I was talking about having to kind of own the EC2 instances underneath the hood when you're building an ECS environment, Fargate does that for you. So it automatically provisions, it does auto scaling, it does all that stuff for you. And so for instance, you can run at 0. So at the end of the day, it's about taking less and less control away, not in a bad way. So having being able to focus more on building our applications instead of having to manage the infrastructure of our applications. So that's Fargate. Really exciting stuff. So the next question then becomes, this is the exciting part. What if I'm not using .NET Framework? What if I get to build something new? How exciting is that? Isaac, tell me you can do stuff that's new in AWS. Yes, you can. We're not just for Windows and .NET Framework applications. Linux or Windows? Still Windows. You'll notice that something's going to happen here. Okay, am I using serverless containers? Go down the exact same flowchart. However, if I'm using Linux, which is the really exciting story when you're building .NET applications, do I want to use containerized apps? Do I want to have serverless apps? Or do I want to use static hosting? So there's a lot of options there. Let's go down the path of using containerized applications. So do I want to have an AWS managed containerized web API, web or an API application? Do I want it to be serverless? Same flowchart as earlier, right? So depending on if you want to use Windows or Linux, you can still use the same services. You can still use ECS or EKS if you want to. However, if you want completely the flexibility to not manage anything, I just want to take my app and I want to run it in the cloud. In that case, I forgot that I had this part too. I don't want to have orchestration by Kubernetes, and then I have Linux containers, right? So this here, are the same as here. All right. But what if I don't want to manage anything? I can use AWS App Runner. In my opinion, it's my favorite AWS service. And here's why. So here's a story for you. So I have AWS Fargate, I have Amazon ECS. So these are layers, right? And then I have load balancing. These are all things that I have to build myself. I have to create an instance of ECS using AWS Fargate. I have to configure load balancing. I have to configure auto scaling. And then I have to configure the CI/CD that's built into that. I mean, that's typically when we're building cloud applications, these are all the things we need to manage ourselves. But what if you took all of those things and had it in one service? That service is AWS App Runner. So think about it like this. I create an AWS App Runner service, an instance of it, and I point it at a Docker image, or I point it at a GitHub repository, and it just does everything else. It automatically creates my service. It containerizes my application if I need it to, so it'll create a Docker file. It will deploy it out to AWS, and it will set up CloudWatch, which is our telemetry and monitoring tool in AWS. It does all of that for me in one go without having to do everything else, right? That's kind of cool, right? Is that cool? People are nodding their head. Some people are nodding their head. I need to convince other people. Let me show you how awesome App Runner is. So, whoops. Come on, mouse. Where'd you go? Oh, I guess I'm not going to use that. So here is a simple .NET application. I can open this up. It's .NET 7, right? And there's nothing really exciting here. It's a MVC app, so I have some CS/HTML files and nothing super interesting here. However, if I do something, and remember I talked a little bit earlier about CLI tools? So AWS has a CLI tool. In one command, I can take that application and deploy it to AWS with one line. So I can do that by going .NET AWS deploy. And what is this going to do? It's going to, one, just based on the configuration settings that I have local on my own environment, where it's going to get deployed to, what region, and that's East US 1. And then it's going to configure where our deployment target is. So in AWS world, we have this idea of stacks, which is basically how we define our infrastructure. And that's using a service called CloudFormation, which is different than the CDK. Let me talk a little bit about that. So CloudFormation is a service that allows you to define your infrastructure using JSON or YAML, right? That sounds very familiar to a lot of folks. What the CDK is it's an abstraction layer on top of that that allows you to programmatically write code like in C# that defines your infrastructure. So you can go, okay, I want App Runner instance that connects to this DynamoDB database that does this, that does this, that does this, but it's all in C#. And when you deploy it, it's called the CloudFormation stack. Does that make sense? Sort of. Anyway, so I ran this .NET deploy global tool, and I already have some CloudFormation stacks that I've already pre-configured, but I want to do another one. So let's create a new one. And then it's going to ask me, in the back, can you read this, or is this kind of small? Give me a thumbs up in the back if you can read it. Cool, all right. So it gives me options. It actually looks at my application, and it says, these are some of the options that you could use to deploy your app to AWS. So I talked about Elastic Beanstalk earlier. I talked about ECS earlier, but the fourth option is the one that I'm interested in. So that's App Runner. So then it's going to say, okay, what do you want the name of this stack to be? The default, if I was just to hit enter, is ASP.NET App 2. So let's do that. So then what it's going to do is it's going to say I need Docker installed because I don't have Docker Desktop running on my machine right now, because I don't have Docker Desktop running right when I start my computer. So I'm going to start Docker Desktop, and then I'm going to run that command again. Maybe I'll start Docker Desktop. There you go. All right. Docker Desktop is starting. We have plenty of time. We have plenty of time. This machine has 64 gigs of RAM, just so we're clear, and it took that long for Docker Desktop to start. That's the problem. Anyway, all right. So let's try that again. So it's going to say, OK, going to do this. We're going to click option. We're going to click that. We're going to click AWS App Runner. I'm going to say that. And then it's going to say, how do you want to configure your environment? So OK, I want to run a port 80. I want 1024 CPU. I want 2048 of memory. And I want the ECR repository name. So I want the image. I want that to be called ASP.NET App 2. So if I click Enter here, what it's going to do is it's going to start building our Docker image. So I didn't actually show this because I wasn't paying attention, but it created a Docker file for me. So running that command took my .NET 7 application, containerized it for me, and is deploying it to AWS without me having to do anything else. Like, that's pretty slick, right? And this works too, like if you were to point it at a GitHub repository, like if you were to go through the AWS console and say, hey, here's a GitHub repo, it'll do the same thing. So that in and of itself is pretty valuable. So the ability to just take some random application and containerize it is pretty awesome. So this is going to do all the things that you're probably familiar with if you've ever Dockerized a .NET app. It's going to build a container image. It's going to publish that container image to Amazon ECR, and then it's going to create an instance of app runner, and then it's going to pull that image down and deploy it to that instance. This does take a little bit of time. So I'm going to move on, and then a little bit later, we're going to go back and we're going to see what that experience looks like. All right. Is everybody doing good? Is this helpful so far? You're a very lively crowd, so I need to make sure people are still breathing. All right. So that is the re-platform section, right? A little bit more exciting. Not like the most exciting thing ever, because there is still like some legacy stuff in there, but like the purple box. Let me tell you about the purple box. So the question was, do I want to use containerized apps, serverless, or static hosting? I went down the path of doing containerized apps. Now we're going to go into serverless function. Who here has heard of AWS Lambda before? All right, most of you folks. Who here has like a Amazon Echo device? Is that a thing in the Netherlands? Or only people in America buy them? Like the little devices that Amazon makes that you can have in your house that say, it's basically a glorified like alarm clock? No? Yeah, Alexa. So like if you build like skills using Amazon Alexa, there are Lambdas behind the scenes. Anyway, so let's talk a little bit about the value proposition of AWS Lambda. So we've talked here, right? Amazon EC2. So like, when from a management perspective, like you're not going to get more opportunities to manage things than with EC2, right? And then as you start to go north or up, you get less and less opportunity to manage things, which depending on your use case might be more exciting. So if you're using Amazon ECS or EKS or even Fargate, less and less management. However, there is an opportunity to not manage anything except for the code that you write, which is like the dream, right? Like I'm just going to take some section of code that needs to act on a particular event and just run it. Does anybody here know like where the term serverless came from? Or at least my version of where the term serverless came from? Does anybody have any guesses? Is it because there's no more servers? No, there's still servers, right? Like your apps are still running. So here it is, and it's very corny, it's very silly, so I apologize. It's because in opportunities when we care about our code more and the server less. Come on, I need a clap. Please, please. Thank you for putting up with that. But no, the ability to just have like some chunk of code that's like, okay, I'm going to drop a file into a storage bucket and then iterate on that file and maybe put it into a database. Or I need to put something onto a queue and then act whenever that message gets put on that queue. Like these are how we build applications today. Like we either build web applications or we build like glorified console apps that have while loops, right? When you think about it, that's what these serverless functions basically are. They're while loops that are, hey, read from a queue. Hey, read from a database. Hey, do this, do this, do that. So the ability to act on those particular events, it's event-driven architecture. So the ability to, whenever something happens, to be able to do things that bring business value. Like, for instance, if you live in the United States and it's the day after Thanksgiving and you own an e-commerce company and you get millions and millions and millions of transactions in one day. The ability to scale on that, the ability to bring value to your customers is most important. So that's why serverless is very interesting. Serverless is also very interesting because of its cost. Like, we have conversations with customers that when they start using Amazon Lambda or AWS Lambda, they come to us and say, I think there's something wrong with your billing. And we say, what do you mean? Well, we ran 1 billion transactions this month and it was like $6. And we're like, no, that's right. And the customer's like, are you sure it's right? The customer is like, feels bad that they're getting all this value for this small amount of money, right? So that's really a good feeling to have, is like when you feel like your customer is very, very excited about the opportunity to bring value at a low cost. So I'm going to hop into a Lambda demo. But before I do that, I want to see if that thing deployed. Nope, still deploying. All right. Sometimes it does take a little bit of time, especially if the internet isn't that great. So let's actually do something else. So I have a .NET application that is a Lambda. So how I was able to do that is I can actually go into Visual Studio and I can just right-click, create a new project. And then this is probably going to take forever because that's how it works. But I can create, if I've installed the AWS toolkit for .NET as well as the Lambda tools, I can actually create these Lambda projects inside of Visual Studio. So I'll just give it a project name, and then it's going to ask me what kind of project, what kind of Lambda I want to create. So I can create an empty function. I can create one that acts on S3, which is like our storage service, or Kinesis, which is our streaming service, and all these different options, right? I'm not going to create one because I've already created one, but it'll basically create me a service that looks like this, which might look familiar if you've built apps that are serverless before. So basically, nothing very exciting here, just a simple function handler that returns a string. So the question becomes like, okay, if I want to test this, or if I want to deploy it, how are some of the ways that I can do that? So when you're building Lambdas in Visual Studio, you have access to what's called the mock Lambda test tool. And that's what this little cool thing is here. So I can click that. And this actually spins up a test harness for Amazon Lambda. And this is what this looks like. So it's a web-based utility, similar to think of it like a Postman, or if you have some sort of Visual Studio extension that does something similar to this. The ability to send sample requests to your running services. And we have a bunch of different sample requests that you can do. In this particular case, I don't have anything. If you look at my code, it just literally every time I do a get against it, it just returns a string because writing demos is awesome. So I can click execute function, and then there, as you can see, oh my gosh. As you can see, it returns that string. So that's cool. I've tested it locally, which is exciting. So the next step then becomes, okay, so what if I want to deploy it to AWS? Well, I can do that too. So I can right-click, because friends don't let friends right-click publish, right? I can publish to AWS Lambda directly. Did that actually get triggered? Nope. So then it's going to spin up a mechanism, upload Lambda function. So I can specify a function name. I can specify the framework, where it's going to go. Click next. And then I can configure additional things. I can configure what the IAM role is. So IAM is how AWS handles security. So think of it like we follow a least privilege model at AWS. So instead of carrying around things like connection strings or secrets, that's all done at the service-to-service level. So you can say this Lambda has access to just this database in this particular capacity. So connection strings aren't needed, which is kind of cool. So I'm going to click upload. And then this is going to publish this Lambda function up to AWS, and then it's going to spin up. It's going to show a new view after it's done that allows me to test against it. So what this does is it builds, publishes, zips, and then pushes up those bits to an S3 bucket, so a storage bucket, and then Lambda gets put on top of that. So when this is done, successful, I can actually run a request against it, and then I get AWS loves.net. So that's pretty cool. And it's not just here, too. Like if I wanted to spin up, do I have time for a demo? Yeah, I think I have time for a demo. Let's go back to this app runner demo before I finish that one. So right here, I have this endpoint now. So it took a little bit of time to run, 333 seconds. So do the math. That takes a long time. So if I click this endpoint here, it's going to open in the browser an ASP.NET Core application with some information about the underlying infrastructure that's running. So at the end of the day, really, really exciting stuff. And I just got the 5-minute warning, so I'm going to start powering through some stuff. So apologize for talking faster. I thought I had 50 minutes, not 45 minutes. That's my fault. So if you have serverless functions, and then what if you want static hosting? So for instance, if you just have some application that is just HTML, CSS, and JavaScript, that's not a .NET thing, right? In what case would you need something like that? Like if you're building ASP.NET Core Blazor, WebAssembly, that application compiles down into HTML, CSS, JavaScript, and DLLs. So you can use something like AWS Amplify, which is a full stack developer experience, which allows you to have applications that don't need a backend server. So that's really exciting. This is the finished flowchart. Isn't it beautiful? All right. Oh, clapping! Yes! All right. So I'm going to talk, as we wrap up, I'm going to talk about some of the tools that AWS provides to make the lives of .NET developers better. So how can I containerize my .NET app? So we have something called app to container, which can take your .NET Framework applications and can containerize them into Windows containers and allows you to deploy them to AWS. And that's really, really exciting stuff. How can I move from .NET Framework to .NET 8? Or to .NET, I guess .NET 8, .NET 7, .NET 6, whatever. You can use the porting assistant for .NET, which is a free and open source tool. All the tools that I'm showing you are free, by the way, that allows you to scan your .NET applications, .NET Framework, and provide you an assessment and potentially migration path to the later versions of .NET. How can I break up my .NET monolith? You can use the microservice extractor for .NET, which you can point it at a project, and it will take, like for instance, if you have a bunch of APIs and controllers, it will take those controllers and separate them out into microservices inside your project for you. And it does it using machine learning. So it's not just, okay, I'm going to take all of these different controllers and map them to individual services. It uses machine learning to combine like-minded functionality. And then finally, a wrap-up. Here are all the different compute services that you can use for .NET today, depending on what you're trying to accomplish, .NET or .NET Framework. And what was the one thing that I wanted you to take away from this? AWS loves .NET. So with that, anybody who took a picture of this particular slide deck, you can take a picture of that and get the slide deck instead. Right? And there's also going to be some cool links to some of the stuff that I showed you. So my name is Isaac Levin. Thank you so much for hanging out with me for a little bit. If you want to see me do this exact same talk in like 6 hours, I'm going to be at .NET Amsterdam doing the same thing. If you want to follow me on Twitter or Twitch or GitHub, please do, Isaac R. Levin. And thank you so much. Hope you enjoy the rest of Future Tech. Take care.